Welcome to Technical Founders. My name is Carlos Lara, AI Technical Founder, and today we will learn natural language processing using the naive Bayes algorithm. In particular, we will be using this algorithm for spam detection or spam classification, which is one of the major applications of machine learning today. Pretty much all of the email service providers have this spam detection system built in. So here our data will be SMS messages, and what we want to do, and we have a classification for each one of these messages, whether it's spam or ham, which means not spam. So we have spam and ham, those are the two classifications, and we want to look at the text, the words in those text messages or SMS messages, and based on the individual words, and based on how frequently each one of those words appears in the data, that's how our algorithm will learn to classify as spam or not spam or ham. Now, the naive Bayes algorithm is fundamentally driven by Bayes' theorem. And in short, Bayes' theorem really calculates the probability of a certain event based on the probabilities of other events related to that one. And naive Bayes assumes that all of the probabilities for all these other events are independent from each other, so they have no direct correlation or dependency. So that's how we are. So suppose we want to calculate the probability of an event. We grab the probabilities of other related events and then use those to get the probability for our event. And we use naive Bayes, not just the Bayes theorem, but the naive Bayes theorem, because we're assuming that all of these events that we take into consideration are independent from each other, and so there's no dependencies, which is a naive assumption, meaning in general there are dependencies, but in practice it turns out that it's very amazingly accurate if you assume that the probabilities of all these different events are independent from each other. So let's jump right into our data set here. And so again, we have our text messages, SMS messages, and we just have an associated value for classifications, binary classification. So whether it's spam or ham, which again, ham means not spam. So those are the two, and this is a preview of the data right here. That's what we have. Now, first of all, let's actually list the files in our current directory. This exclamation mark here allows you to run bash commands from Jupyter Notebooks, which is very nice. And now here we will jump into our pandas here. We're going to import pandas as PD, and we're going to call the read table function from the pandas module here, and we're going to use our file path. So our data is this SMS spam collection text file in the folder of the same name, and so we're going to load it here into a pandas data table here, data frame. So we have the separation parameter here. We just put them in the individual rows here. Header, we just say none, and for the names of the columns here, we just specify label and just SMS message. So this is what it actually looks like when we're just printing out the head here. So the top 5 rows, the first 5 rows of this data frame. So we have our SMS messages, and then we have the associated label, which is spam or ham. Very nice. So that's how we're going to start. And remember, the 7 steps of machine learning is so gather data, prepare data, and then we jump into training, evaluation, hyperparameter tuning, and so on. So here we're going to do data processing now. So now we have a basic understanding of what our data set looks like. Now we have to convert our labels here, ham and spam, into binary variables, integer values, 0 and 1. And the reason is, and if you've done machine learning or deep learning before, a machine learning algorithm or a neural network, they don't work really by taking in English, by just taking text data by itself. It takes mathematical data, numerical data, and that's how we do it is we convert our words, our English words, for example, into numerical values. And in fact, that's why tensors are so valuable and so fundamental, because they're a way of representing numerical data in the form of an n-dimensional array. And that's because neural networks or machine learning algorithms, they don't speak English, they speak mathematics, and that's the language that we use to communicate with them. So we just want to convert spam and ham into 0 and 1, into those labels. And in particular here, we're using also scikit-learn, and scikit-learn only deals with numerical values. So let's go ahead and, so for our label column here, we're going to do a mapping function here. So we're going to call df.label.map, so call this map function here, and we're just going to map our columns, ham and values, ham and spam, into 0 and 1. So ham will become 0 and spam will become 1. And here we just print it out, and as you can see, they have been converted into integer values 0, 0, and 1. And here we printed out the shape just so you can see that we have a large collection of text data, so 5,572 rows of data, and then just 2 columns here. Now we're going to introduce the concept of Bagofwords, which is a term used to specify problems where we have a collection of text data that needs to be worked with. So the basic idea is to take a piece of text and count the frequency of the words in that text. Now, and it is important, and we have to understand also here that the Bagofwords concept treats each word individually, and the order of the words doesn't matter. And for our purposes, it will be more than enough to accomplish our goal here of classifying SMS messages as spam or not spam. So we'll start first with an example. We'll do it actually from scratch. There's actually scikit-learn has a method called count vectorizer. Well, and count vectorizer will convert. We'll do that for us, but we'll do it from scratch just so we have a deeper understanding of how that function works behind the scenes, and then we will just call it afterwards. And we'll start with a sample here, simple text data sample here, just a list with 4 strings corresponding to 4 SMS messages. Now the count vectorizer function from scikit-learn will automatically convert all of our words to lowercase, and the main thing that it does here is tokenize our strings. So here it's going to split each word in each one of these sentences, and so it's going to have the words individual. So it's going to have a list of words, of individual words. So that's one, and it's going to assign an ID integer to each one of those words, which we call tokens. This process we call tokenizing, splitting into sentences into individual words and assigning an integer ID to each one. And then it just counts the occurrence of each one of those tokens, because that's actually, again, how we're going to do our naive Bayes algorithm implementation. We're going to look at the words that appear in the data in our text messages, and then count the frequency of those words, and based on that, our algorithm will classify as either spam or not spam. So let's do it real quick from scratch here. So we just create a list here with our sentences, which are strings here, just a list of strings. So we have 4 just to learn how to do it. Now, first of all, we're just going to convert all of them to lowercase, because we don't want the algorithm to be quote unquote biased or to classify differently based on whether the word is capitalized or not. So best practice is to put everything in lowercase. So we'll do a simple list comprehension here. So for I in documents, so for each string in the documents, we just call the lower function on it. So it's going to turn everything to lower, and we print it, and it's the same one, this same list is just all with lowercase. Now we also want to remove the punctuation, because we're going to assume that it's irrelevant for our classification. So here we're going to have to import string, and so we're going to create a variable here, and we're going to do another list comprehension. So for I in lowercase documents, so for this new list with lowercase that we created, we are going to call the translate function on each one of them. So we're going to call translate, and then we are going to, and it's just a transformation basically here to remove punctuation. So as a parameter, it's going to take in this str, string.makeTrans, and we're just going to replace the punctuation with just empty strings or nothing. So this essentially what this does is grab each one of these strings in the list and just remove the punctuation. And we print it out, and as you can see, it's the same thing we had before. It just removes the punctuation. So very nice. Now the next step is to split each word in each one of these strings. So we're going to have a list of words for each sentence. So here we're going to do yet another list comprehension. So for I in this sans punctuation documents, we're going to just call the split function on it, which will split the word. So we have a list of lists, and each list is just the words that appear there here. So now we're getting a lot closer to what we actually want. So again, this is just part of the NLP pre-processing of data, going from text to numerical values. Now the next one is to count the frequencies of the set of unique words in our data. So we're going to use the counter function here. We're going to import it from collections. So we're going to do another list comprehension, and here we have our pre-processed documents. So for I and pre-processed documents, so for each list in the list, we're just going to pass that list into the counter function, and it's going to count the frequency of each unique word here. And we're just going to add it here into this new list, and then we're just going to go ahead and print it out. And as you can see, we have a list of counter objects, and what this counter object, when you pass in a list of words, it returns a dictionary essentially that maps each unique word. So that's the key, and the value would be how many times it appeared there in that word. So that's what we have here. So we have implemented the Bagofwords process from scratch. And this is essentially a frequency distribution dictionary, which gives us a clear view of the text that we're dealing with. So now that we have a solid understanding of what's happening behind the scenes, now we're going to use implemented Bagofwords with scikit-learn. So we're going to do the same thing, the same sample text here, documents, but now we're going to import count vectorizer, which will do everything for us, from sklearn.feature_extraction.text. And the first step is really just to create an instance of that object. So we just call count vectorizer constructor here and assign it to a variable. So we have an instance of our count vectorizer. Now we're going to do the data pre-processing with it. So here it has multiple parameters, and here we can actually print out the object, and it's going to print out all of its parameters. So it has the lowercase parameter that we did before, and here in this case it has a default value of true, of course, best practice, then a token pattern. So here's just how it's going to, so here basically it has a regular expression here as a default value, which ignores all punctuation marks and treats them as delimiters. So just that's actually what you want. And then another important parameter is stop words. Now, if you set it to English here, it's going to remove all of the words from our data that matches a list of English stop words in scikit-learn specifically. So what are stop words? Stop words are words that don't really reflect the core meaning of our text data. Like for example, am, I, is, like just words like that don't really that we don't really take into account when making a classification. They don't really convey a core meaning for a sentence. It's just something that almost every sentence has some kind of those words. So we want to ignore those words. For our algorithm, we want our algorithm to ignore those words. So we call those stop words, and we set the parameter to English, and it'll ignore those. And scikit-learn internally has a list of what are those words. So we're just going to focus on important words. And in our case, are spam. Typically, spam are like words, for example, price or free or cash. Those will be like words that identify that are kind of red flags for spam, but a word like is, am, those are words that don't really make any difference. They don't convey any meaning for whether it's spam or not spam, so we just ignore those. So importantly, it's important to have the stop words. So again, printing out, have our parameters. You can take a look. Now we're going to fit our data, our documents data here, to our count vector object here. So it's an instance of our count vectorizer. We just call fit and pass in our data, our documents here. And let's actually call the get feature names method here. So we have the fit method and the get feature names. And the feature names here for the count vectorizer are the set of unique words. We also call it the vocabulary. These are the unique words that appear in the whole data set combined. So those are the features here in this case, because we're doing natural language processing. So the vocabulary are the set of unique words are our features. Now we don't want just the text data, just strings like that. We want to convert it to numerical values. So we want to create a matrix, an array that contains, so the rows being the SMS messages. So in our case of documents here, these will be our 4 rows, our data points, and the column, and we want the feature names to be the actual columns. And in each like row, column, and in each spot, we want to assign the frequency of words. So for the first SMS message, so for the first text message, the first element in our data set, for the word R, what's the frequency of R, call, and so on. For each one of these words, what is the frequency? How many times it appears in that? So now we have something that actually looks more like a tensor, as we've seen in deep learning. So a numerical representation, a transformation of our text data into numerical values. And that's what our algorithms understand. So we have that, and now we're actually going to convert it to we're going to get a frequency matrix here. This is like not enough. It's not clean enough for us to see what's going on. So we're going to just create a Pandas data frame here. So pd.dataframe, and we're going to pass our doc array that we created here. And the way we created is just to call the transform method on our count vectorizer object. We pass in our documents and then call toArray on it, and that's how we do the conversion. And that transformed data here, we just pass it into our pd.dataframe, into our data frame here as the first parameter, and then we set the second parameter here, the columns, and we just call the get feature names as we did before. So those will be our features, our columns. And now we have a very nice, just visually speaking, we have a very nice Pandas data frame that contains our vocabulary, our set of unique words in the whole data set, and then the rows represent the text messages, so each data point, and then just the frequency of words for each word for each sentence. So very, very nice. That's actually, this is what we want. So there we go. We have successfully implemented a Bagofwords problem for the document data set that we created. Now feel free to pause at any moment and just at your own pace, just make sure that that everything makes sense. Put a lot of information here. Now we're going to go ahead and create training and testing sets, because now that we have gathered the data, prepared the data, we also need to get ready for training and evaluation. So we need to split our data into training and testing sets, in this case for our machine learning problem. So here we're going to import train test split from sklearn.model selection. So this is a nice function here that will split our data into xtrain, xtest, ytrain, ytest. So these are the features and these are the labels. And here we pass in the parameters here. So our data frame, from our data frame instance object, we grab the column SMS message. So we grab that for our features, and then we grab the label one for our labels, for our y. So it's x, y, and random state, just set it equal to 1. And let's go ahead and print it out. And as you can see, we have the total number of rows in our data set, so our SMS messages. And then here we have the number in the training set and the number in the test set. So if you do the math here, it's actually 75%, 25% split. That's how we split it here. Because it's a relative, even though, I mean, it's a relatively small data set, that's why we can split it 75-25. But in practice, if you have a very, very, very large data set, much larger than this, the split can be more, for example, 85-15. So you can have more training data and less test data as your data set grows. Right, so here we're going to apply the Bagofwords processing to our data set. So we're going to just recreate our count vectorizer here object here, and we're going to create training data and testing data, and this is what we're actually going to be using. So we call on our object, we call the fit transform on the training data, so we can do the fitting the data and then transforming it all at once in this one method, and we just pass the x train here. And then we get our training data. And then for the testing data, we want to call only the transform. We don't want to fit it. Again, we don't want to learn features from our testing data. It's only used for testing. We're only learning from our training data. So we're only going to call the transform on it. And we just pass the x test, the features for testing. Now here we have added some Bayes theorem implementation from scratch. If you want to actually pause and just learn at your own pace here, feel free to pause here and just look at this information. This is not related to the spam classification, just information for your own learning. If you want to go deeper into it, how Bayes theorem works, formulas, and so on. So here, feel free to just pause here periodically and just go through this. We're basically using Bayes theorem to just calculate some probabilities. Like for example, for examples that you would use in the medical field, right? Like probability of diabetes based on other probabilities. Just practice for how to implement the naive Bayes, just a deeper understanding. So we have a naive Bayes implementation from scratch with more than one feature. Again, feel free to just go through this on your own, because what we want to do here is really spam classification. We just added here for your own benefit, for your own learning. But now we want to actually implement naive Bayes using scikit-learn. So now that we created our training data and our test data before with our count vectorizer, now we want to actually go ahead and fit our training data and just see what we just evaluate the performance of our model. So here we're going to import the multinomial naive Bayes NB, multinomial NB from sklearn.naive_Bayes. And we're using a multinomial naive Bayes NB because our data is discrete. We're using binary classification for discrete features. I mean, we're dealing with word counts for text classification and just whether it's spam or not spam. But if you were dealing, for example, with continuous data, then you might use, say, Gaussian distribution. So you would just import Gaussian NB, for example, instead of multinomial. So here we just create an instance of our multinomial naive Bayes here, and we store in our naive Bayes variable, and we just call the fit method on it. And we fit our training data and our labels. So that's how our model is going to learn. So this is the fit method that really does the learning. So we have our training data, and then we have our labels, our Y labels, and we created that before. Just to show you real quick. So yeah, right here, this is where we created our data, and then we created these training data and testing data after transforming the data further. So here we fit that, and then we just get our predictions. So we create a predictions variable here, and for our naive Bayes object, we just call the predict on it. So this is after learning. So it learned from the training data, from the labels, optimized, and we just call predict on the testing data. And now it's going to give us our labels, and we're going to compare the predictions to the actual Y test, and just calculate our performance metrics. So let's go ahead and evaluate our model. So we have accuracy, precision, recall, and F1 scores. There's various values here, various parameters. I guess you can call them performance metrics that you can use. Feel free to pause and look at it on your own. But accuracy basically measures how often the classifier makes a correct prediction. Precision tells us what portion of messages were classified that we classified as spam were actually spam, and so on. So here we're going to import. So from sklearn.metrics, which is very, very nice module here, the metrics, we're going to import accuracy score, precision score, recall score, and F1 score. So there's a bunch of functions here that you can import for testing the performance of your model. So we're actually going to call the accuracy score function here and passing as parameters our Y test, our labels, our test labels, and then our predictions. And it's just going to calculate, I mean, similar to deep learning, right? We calculate we see the difference between our predictions and what we actually wanted our model to predict. So the actual values from the actual predicted values, and we just calculate accuracy, precision, and so on. So our accuracy here is really, really good with limited amount of data, and it just takes like a second or less than a second to run. I mean, it's just very, very extremely fast. I mean, that's one of the benefits of the naive Bayes algorithm with scikit-learn. It's just very simple to use, very, very fast, and very accurate. I mean, it classifies our data correctly, basically 99% of the time. Very high precision, 97%, recall, F1 score, so very extremely good performance metrics here. So interestingly enough, like just naive Bayes, by assuming that the probabilities are independent of the probabilities that you're taking into account, we're assuming that they're independent from each other when they may not be. It's a very good approximation to get very, very good accuracy. And again, this is natural language processing because we're dealing with text data. We're processing text messages. We're looking at the individual words and how often those words appear in those messages, in those sentences. So thank you. That's it. Natural language processing with naive Bayes algorithm for spam classification. Thank you for watching. If you have any questions, thoughts, comment below, and I will see you next time.